students. I, Mansi Solanki, welcomes you in Anvira Online School. Today we will discuss part 3 of our chapter number 10, Straight Lines of Mathematics NCERT. From before this we had already discussed about the basic before exercise 10.1 and the question number 1st to 7th of our exercise 10.1. So now I will start up with question number 8. Question number 8 states that find the value of x for which the points x, -1, 2, 1 and 4, 5 are collinear. Since we have studied for the condition of collinear, if point A, point B, point C, if these points are collinear, then slope of AC is equals to slope of BC. We have already discussed that if the slope of AC is equals to slope of BC, if both the lines have same slopes, then we can say that these points are collinear with each other. So now applying this concept here, we will get, let A is equals to x, -1, B is equals to 4, 5 and C is equals to 2, 1, or you can write it as B and C. So for condition of collinearity, slope of AB should be equal to slope of BC. So let us find the slope. As we know that slope is given by the formula m is equals to y2 minus y1 upon x2 minus x1, where x2 and x1 are not equals to each other. So first slope of AB, that is y2 minus y1, 5 minus y upon 4 minus x is equals to 1 minus 5. Here y2 minus y1 divided by x2 minus x1, 4 minus 2 minus 4. So what will I get? 6 upon 4 minus x is equals to minus 4 upon minus 2. So 12 is equals to 16 minus 4x. That means 4x is equals to 16 minus 12, that is x is equals to 4 by 4, that is 1. So the value of x is 1 and point A can be written as 1, minus 1. So we had find the value of x for what? For this we have applied the condition of collinearity. In this we know that slope of AB is equals to slope of BC, or slope of AC is equals to slope of BC. You can write it in any way you want. B can be this, B can be this point. You let it as. So the value of x is 1. Take a screenshot of this. Now the question number 9. Question number 9 states that without using distance formula, show that the points -2, -1, 4, 0, 3, 3 and -3, 2 are the vertices of the parallelogram. So how can we prove that these are vertices of parallelogram without distance formula? We know that in an parallelogram the two opposite sides are parallel to each other. So first we prove that both the sides, opposite sides are parallel to each other. And how can we prove the sides are or the equation of lines are parallel to each other? For parallelity of two lines, we have the formula. We know that the slope of m1 or m2, the slope of two lines that are m1 and m2 should be equal to each other. So we will find the slope of opposite sides and then we will prove that if these vertices are the vertices of parallelogram or not. So first of all, I made a parallelogram in which point A, B, C and D. So here -2, -1, 4, 0, 3, 3 and -3, 2. If these are the vertices of parallelogram, then the slope of AB should be equals to slope of CD. Similarly, the slope of AD should be equals to the slope of BC. So let us find the slope of every sides. First of all, we know that slope of a line is m given by the formula y2 minus y1 upon x2 minus x1. So now slope of line AB I can write it as m1. Slope of line AB is y2 minus y1, that is 0 minus 1 divided by x2 minus x1, that is 4 minus 2. So slope will be 1 by 6. Now slope of line BC, that is m2, is given by, how can I find the m2? 3 minus 0 divided by 3 minus 4, that is equals to minus 3 by 4. Similarly, slope of line CA, that is m3 is equals to CD. m3 is equals to y2 minus y1, 2 minus 3 divided by x2 minus x1, that is minus 3 minus 3. This should be equals to minus of 1 by minus of 6, that is equals to 1 by 6. Similarly, slope of line AD, that is m4. m4 is equals to 2 minus 1 divided by minus 3 minus 2. That is equals to 3 by 3. Here 3 minus 4 is what? 1. So here minus 3. Here also we get minus 3. So we can say that AB is parallel to CD since the slope of AD is equal with CD. So for parallelism, slope of AB should be equals to slope of CD. So what is our slope of AB? Slope of AB is 1 by 6, and similarly slope of CD is slope of AB and slope of CD. CD is also 1 by 6. So I can write it as AB is parallel with CD. Similarly, BC slope of BC is also equals to slope of AD. This gives us minus 3 is equals to minus 3. Then we can write it as BC is parallel to AD. Hence, ABCD is a parallelogram and given point vertices are vertices of a parallelogram. So what we have done, we find first of all the slope of every line. We know the condition of parallelism. Condition of parallelism states that both the slope, if two lines are parallel, then the slope of both the lines should be equal. We find the slopes of both the lines should be equal, then we will conclude that ABCD is a parallelogram. If ABCD is a parallelogram, that means the given vertices are vertices of parallelogram. Here we prove the quadrilateral as a parallelogram without using the distance formula. So let's take a screenshot for this. Now the question number 10. Find the angle between x-axis and the line joining the points 3, minus 1 and 4, minus 2. Find the angle between. So let we have an line. line कौन सी given है हमें? 3, minus 1 and 4, minus 2. ये दो पॉइंट्स है जो किसी लाइन से पास हो रहे हैं, ठीक है, और हमें एक्स एक्सिस और उस लाइन के बीच का एंगल फाइंड आउट करना है. सो दैट मीन्स वी हैव टू find it out the theta, that means angle of inclination with respect to x axis of the given line. So first of all we have to find it out the slope. What is the slope of AB? Where A is my point 3, minus 1 and B is 4, minus 2. The slope of AB, that is M. And we know that formula for M is y2 minus y1 upon x2 minus x1. So M is given by, what is my y2? Minus 2 minus 1 divided by 4 minus 3. That is equals to minus 1 upon 1, that is minus 1. So here the value of my slope is minus 1. So how can I find the theta? We know that the relation between slope and theta is m is equals to tan theta, where slope is given by tan of the angle of inclination. So here I put the value of m is equals to minus 1. So 1 is equals to minus of tan theta, and we know that where the tan theta is negative, that is tan 180 minus theta. So from here we conclude what is our 1? Tan 45 is equals to tan 180 degree minus theta. So the value, removing the tan from both the sides, I will get, so theta is equals to 180 degree minus 45 degree. So theta is equals to 135. So first we will find what we have to find it out, the angle of inclination. For angle of inclination, first we find the slope of line by using the coordinate system. Then we know the relation between the slope and the angle of inclination is given by m is equals to tan theta. Here 1 minus 1 is equals to tan theta. 1 we know that the value of 1 is tan 45, and minus theta can be written as tan minus theta can be written as tan 180 degree minus theta. So here I apply, and the theta angle of inclination, the required angle of inclination is 135 degree. Now the question number 10. If the slope of a line is double of the slope of the another line, so mark it as important, it is an important one. If the slope of the line is double the another slope, so let the slope of a line is m1 and it is given, and the slope of another line is slope of second line is m2. So what we have given the relation between m1 and m2, m1 is equals to 2 times of m2. So if the tangent of the angle between them is 1 by 3, tangent of the angle between them, let the angle between them is tan alpha. If the angle between them is alpha, this gives us, it is given that tan alpha is equals to 1 by 3. So let us recall the angle between the two lines is given by tan alpha is equals to m2 minus m1 upon 1 plus m1 m2. So now let us put the values. So tan alpha is equals to m2 minus m1, that is m2 minus 2m2 upon 1 plus m1 2m2 into m2. So tan alpha can be written as minus m2 upon 1 plus 2m2 square. Since we have given tan alpha is equals to 1 by 3, so I can write it as 1 by 3 is equals to m2 1 plus 2m2 square. So this will gives me 1 plus 2m2 square minus 3m2 is equals to 0. Now find the factors of this equation. We will get 2m2 square minus 3m2 plus 1 is equals to 0. So on factorizing, I can write this equation as 2m2 square minus 2m2 minus m2 plus 1 is equals to 0. So from here 2m2 I will get m2 minus 1, and from here minus 1 m2 minus 1 is equals to 0. So either 2m2 minus 1 is equals to 0 or m2 minus 1 is equals to 0. From here we can conclude m2 is equals to 1 by 2 or m2 is equals to 1. So what we will get, m2 is equals to 1 by 2 or m2 is equals to 1. So if case first, if m2 is equals to 1 by 2, then m1 is equals to 2 into 1 by 2, that is 1. Or if case second, if m2 is equals to 1, then m1 is equals to 2 into 1, that is 2. So the slopes of lines are 1, m1 is equals to 1 and m2 is equals to half, and slope of lines are either this or m1 is equals to 2 or m2 is equals to 1. So we can get that if the m2 is equals to half, then m1 is equals to 1, and if m2 is equals to 1, then m1 is equals to 2. The slopes are double to each other, and we will find the slopes of both the lines. Now let's take a screenshot of this. Now 1 plus 2m2 square is equals to minus 3m2. So 2m2 square plus 3m2 plus 1 is equals to 0. By factorizing it, we will get 2m2 square plus 2m2 plus m2 plus 1 is equals to 0. Taking 2m as common, I will get m plus 1. Similarly, from here again m2 plus 1 is equals to 0. So I can write it as 2m2 plus 1, either 2m2 plus 1 or m2 plus 1 is equals to 0. From here I will get m2 is equals to minus half, and from here m2 is equals to minus of 1. So we will take cases. If for case first m2 is equals to half, then what will our m1? m1 is equals to 2 times of m2. So it will be 2 into 1 by 2, minus of 1 by 2, that is minus 1. And similarly for case second, m2 is equals to minus 1, then m1 is equals to 2 into minus 1, that is minus 2. So the required slope of the lines are m1 is equals to minus half, then m2 is equals to minus 1, and if the m2 is minus 1, then m1 is equals to minus of 2. They both are double to each other. So the required slopes are minus half and minus 1, or minus 1 and minus 2 for the second case. So what we had done in this, we take the equation of slope tan alpha is equals to m2 minus m1 upon 1 plus m1 into m2, where tan alpha is given by m2 minus 2m2 here. From equation we had given, the first equation is double to the second. So we apply here, we find the quadratic equation. Then after solving these equations, we get two cases. Since we get two values of m2, so we will find the two different values of m1. So either we can take first case or second case. Now the question number 12. A line passes through x1, y1 and h, k. If the slope of the line is m, show that k minus y1 is equals to m h minus x1. Then how can we find it, this condition? As we know, we have given the slope. So what is the formula of our slope? M is given by, slope of any line is given by slope of a line, that is m here. For here we take m, that is y2 minus y1 upon x2 minus x1. Here the coordinates are given x1 y1 as x1 and second coordinate x2 y2 is given by h, k. So applying these coordinates here, what we will get? What is our y2? That is k. What is our y1? That is y1. Similarly, what is our x2? That is point h. And similarly, what is our x1? That is x1. So I can write it as m is equals to k minus y1 upon h minus x1. By arranging this, m is equals to h minus x1 is equals to k minus y1. So, comparing the equation, first A and B, we will get both the equations are same. So, hence prove that k minus y1 is equals to m h minus x1. So, only just we had concluded the formula of our slope, and after applying the formula of slope we will get the condition or this. And now take a screenshot of this. We will discuss question number 13. Now we will discuss question number 13. If 3 points h, 0, a, b and 0, k lie on a line, show that a by h plus b by k is equals to 1. 3 points are lies on a line. That means the condition we will apply here, the condition of collinearity. So how can we apply the condition of collinearity? We know that if 3 points are on single line, then these 3 points are collinear to each other. So the condition of collinearity is, what is our condition of collinearity? Slope of AB is equals to slope of BC. Here let A is equals to h, 0, B is a, b and C can be written as 0, k. So slope of A, slope is given by y2 minus y1 upon x2 minus x1. So applying here, slope of AB is equals to y2 minus y1, that is b minus 0 upon a minus h, that is equals to b upon a minus h. Similarly, slope of BC is given by k minus b upon 0 minus a, that is equals to minus of k minus b upon a. So apply both the values of, equating both the values of slope we get b upon a minus h is equals to k minus b upon minus a. So minus ab is equals to k minus b into a minus h, that is equals to minus ka minus hk minus ab plus bh. So I can write it as minus ab cancelled out, so it can be written as ka plus bh is equals to hk. For arranging this equation in the form of, in that form, since we have to show this one, I will divide the whole equation by hk. So divide the above equation by h into k. So what we will get? K by a upon hk plus b by h upon hk is equals to hk upon hk. So what we will get? K to k cancel, h to h cancel, and hk is cancelled with hk. So we get h a upon h plus b by k is equals to 1. Hence proved. Hence we got the same condition that was given in our question. So first we applied the condition of collinearity, since these all points are given on a single line. After applying this, we will get the equation, the formula of slope. By formula of slope, we will find the slope of both the lines. Then after finding the slope, we will equate them. After equating, we will divide them by hk for finding the condition given as it is. So here completes our question number 13. Let's take the screenshot and we will go further for the question number 14. Now let us consider the last question of this exercise, the question number 14. Consider the following population and year graph. Find the slope of a line AB and using it find what will be the population in the year 2010. Here we had given a graph in which there is a population in crores and years are given on the x-axis and population is given on the y-axis. We have to find it out the slope of AB. How can we find it, the slope of AB? By using the coordinate system, that is y2 minus y1 divided by x2 minus x1. But here not our question is completed. We also find what will be the population in 2010. Since 2010 is also comes to this line also, so 2010, the x coordinate is 2010 and y coordinates we have to find what is the population. So I taken a point C on where whose x coordinates are 2010 and y coordinates we have to find. How can we find? We find it by the condition of collinearity. The slope of AB will be equal to the slope of BC since both are on the same line. So these points are collinear to each other. So let us first find the slope of solution. First find out the slope of AB. Slope of AB is given by m is equals to y2 minus y1 upon x2 minus x1. What is the slope of AB? That is y2. What is our y2? 97 minus y1 is 92 divided by x2. x2 is 1995 minus 1985. That is 5 by 10. So slope of AB is 1 by 2. Here we find the slope of AB. Now we will find the population in the year 2010. For population we know that condition of collinearity is slope of AB is equals to slope of BC. Slope of AB, we know that it is 1 by 2. And what will be the slope of BC? Slope of BC is y2 minus y1, that is y minus 97 divided by x2 minus x1, 2010 minus 1995. So from here we will get 2009 minus 1915 is equals to 2y minus 184. Sorry, 194. Then from here we get 2y is equals to 194 plus 15. So y is equals to 209 divided by 2. So y is equals to 104.5 crore. Since it is the population given, so it is 104.5. So the population in 2010 will be 104.5 crore. So I hope you got understand how can we find the slope, and then for applying the condition of collinearity we find the value of population in 2010. Here we completed with our exercise 10.1. In our next part we will do the next topics of this chapter, 10 straight lines. Thank you all.